9. Let's just go over a couple. How do we know if well, it says for the given polynomials, determine which of the binomials listed are factors. So how do I know if a particular binomial is a factor? If I do the synthetic division and the remainder is a 0. The trick is, what number do I plug in to represent x plus 1? -1 goes in the box. So you set the binomial equal to 0, and you subtract the 1, and you get x equals -1, and that goes in the box. So -2, 15, -7. So I bring down the first term, then I multiply 1 and -2 to get 2. And that gives me a 17, excuse me, a -34. So A, the answer would be yes or no? No, because 7 minus 34 is -41, and I'm looking for a 0. So, did I mess up? Well, let's look. So I brought down the 2. -1 times -2 is 2. 15 and 2 is 17. Oh, I times it by 2. Thank you. So -1 and 17 is -17, so it should be -24. Does that make more sense? Okay. But it's still a no. All right. So if I change to 7, I bring down the -2. 7 times 2 is -14, which gives me a 1. 7 and 1 is 7. 0. So B is a yes. Okay. Do I have to test C? How do you know C is not a factor? Well, what is the resulting equation? If I started with an x to the squared, x to the second, what is my resulting equation going to look like? Well, I started with an x to the second, so I'm going to end with an x to the first. So I have -2x plus 1. Well, does this factor match that factor? No, so it's not a factor. Now, I can only do that because I dropped from an x squared down to an x. On number 2, C is a no, yeah. Okay, 2, I might be able to, let's say that A works on number 2. Well, then I could tell if my answer was B or C just by looking at the numbers that are left. But on number 3, that won't work. If I start with an x to the third and I try x plus 2 and it works, then I don't know anything about the other two because I'd have an x squared equation. So sometimes that works, sometimes it doesn't, depending on how big it is. Okay, so that's part of your assignment tonight. And now I want you to look at that packet that you picked up. How many of you have graphing calculators? We're doing much better. You're going to want them before we take the test, or you'll be in some serious trouble. Oh, test will be maybe the end of this week. It depends. We'll see. All right. So we're going to look at something called polynomial end behavior. So in this lab, we are looking at the end behavior of polynomial graphs. What is happening to the y values at the ends of the graph? Okay. So we're going to look, as we travel left or right, we're going to look at where the graph is headed. And we're going to notice some patterns, and we'll be able to make some conclusions just by looking at the equations. In other words, we're interested in what is happening to the y values as we get really large x values and as we get really small x values. So basically, what's happening to the graph as I travel to the right, or what's happening to the graph as I travel to the left? Is it going up or is it going down? Right? Recall a polynomial function is one that can be written in the form. Now that's a really complicated way to say like 6x to the fifth minus 7x to the fourth, and so on. And polynomials can be huge. You could have an x to the 1 millionth, and then have a million terms that follow. Okay? But that first term, the biggest power, determines the shape of the graph. So if we had an x to the 1 millionth polynomial, that first one is going to dictate what our graph looks like. Okay. To get an understanding of how we will denote end behavior, let's look at x to the third. So if you have your calculator, and mine's turned off, go into y equals and graph x to the third. So if you go into y equals, clear out whatever graph is there, and just type in x raised to the third, and push graph. Did anybody not get a graph that looks like just like this? Yours needs to be. So push zoom 6 for standard. Oh, it's not working at all. Push on. Okay, now try it again. Hit graph. While it's graphing, don't push any buttons. That's what happened. All right. So an x to the third graph looks like this. Okay. Notice how the y values soar off towards infinity on the right end. So what that means is, if I were to walk along this line towards infinity, if I were to walk forever, is the graph in that direction going up or down? It's going up. Will it ever come back down? No, it's just going to get higher and higher and higher. Okay? And the y values soar off toward negative infinity on the left end. So if I were to walk in the opposite direction, if I walk in the negative direction, notice that the graph is going down, whereas on the other side it's going up. Okay, now here's where it gets a little bit tricky. We have to describe two things at once. We have to describe the x direction and the y direction at the same time. And we do that by writing as x approaches negative infinity, y approaches negative infinity. Okay, let me show you how we're going to do this. We're going to use what is called limit notation, which is a really simple version. So we're going to say the limit, we abbreviate that LIM, the limit as x approaches infinity. That's what that means. Okay? The limit as x goes to infinity. Is that moving in the direction to the right or to the left? To the right. Because on the number line, so let me get to where we can see that again. So here's my graph. So the limit as x approaches infinity of the function, and our equation is x to the third, equals, and this is our y value. This is our y value. If we go forever to the right, what would our y value be? positive infinity because it's going up. So the limit as x approaches infinity of x to the third is infinity. Because as x gets bigger, y gets bigger. Okay? Now let's look at the other side. The limit as x approaches negative infinity, which means as x goes to the left, and our equation is x to the third equals, what direction is y going if I move to the left? It's going down, so we're approaching negative infinity. This is read as x approaches negative infinity. So as x gets smaller, the y value also gets smaller as it approaches negative infinity. Okay? Now, if the equation's really big, you know, if this part of the equation was like x to the 16th, something, 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 I would let you just call it f of x, or g of x, or h of x, and then you wouldn't have to write the whole thing out. So I'll show you that in a little bit. So let's look. Turn the page. This worksheet will guide you through looking at the end behavior of several polynomial functions. At the end, we will generalize about all polynomial functions. A good window for the graph would be from negative 10 to 10 for the x's, and negative 25 to 25 for the y's. So go into your window. So push window. Your x's are already from negative 10 to 10. We need to change our y's to be negative 25 to 25. Does anybody know what HSCL means? SCL? YSCL? The scale. What does the scale tell us? It tells us how big. It tells me how big each little tick mark is. So if I did 1, that would be 50 tick marks. That would be kind of hard. So let's count by 5s. So if I count by 5s and I push graph, now we've kind of crunched the y-axis down. Now instead of from negative 10 to 10, it goes all the way down to negative 25 and all the way up to 25. So what I want you to do is graph all 3 of those equations one at a time. So graph this, but we'll just do one together. So let's graph the first one. So y equals, read that off for me, somebody. 2x to the third plus 4x. Is that it? Okay. Then push graph. And it looks like this. Now I want to describe the end behavior. I want to know what happens on the left and what happens on the right. So for the right side, I'm going to write down the limit as x approaches, what's the number on the right? Positive or negative? Positive infinity. So as x goes to positive infinity of 2x to the third plus 4x, that equals, what happens as I go to the right? The y value is going up or down? Up, so it equals infinity. Okay? So the next one, the limit as x approaches negative infinity, which is the left side, of 2x to the third plus 4x equals up or down? Down, so it would be negative infinity. Okay, I want you to go ahead and do the other two graphs. So looking at these three graphs, the end behavior is the same for all of them. So what is similar between the equations? There's something about the equations that make all of the end behaviors look the same. What do you notice about those, each one of those polynomials? What's that? Good, they all have the same end behavior. So the limit as x approaches infinity of the function is always infinity for all three graphs. And the limit as x approaches negative infinity of the function is always negative infinity. Well, you can't. I can put f of x. I was representing all of them at once. So you need to write the functions in there. So why do all of these look similar? I mean, this one has this funny little turn in it, but there's something about those equations that make them have the same end behavior. Do you notice anything about the equations that might lead to the same end behavior? Not yet? Okay. Well, hang on to that for a second. Look at the next page. So let's graph the first one together. So the first graph is going to be -3. Oh, hang on. -3x to the third. Oh, sorry. Thank you. The fifth minus 5x squared plus 3x minus 4. So if I were to draw this one, and I were to look at the limit as x approaches infinity, and these get kind of long, so go ahead and just name these. I'll call this one f of x, I'll call this one g of x, and h of x. So the limit of f of x is, on this graph as I move to the right, what direction does the y value move? It goes down, negative infinity. And the limit as x approaches negative infinity of f of x. So as I move to the left, which way does the graph go? It goes up. So it equals infinity. So here I have an x to the fifth. If I look back on the page before, this one is also an x to the fifth. What changed? Where? The first term. So notice on this graph, my x to the fifth term, the biggest one, is positive. On the next page, my biggest x is negative. And that's going to change the end behavior. Okay? Now, something else is in common. Do you notice anything about the first term in all of those? So I have an x to the third, an x to the fifth, and an x to the seventh. What do all of those have in common? They're all odds. When you're dealing with an odd degreed polynomial, meaning the biggest exponent is odd, your end behaviors are going to be opposite from each other. If it's an x to the ninth, one side will go up and one side will go down, or the other way around. So if this were an x to the ninth, would it be a positive x to the ninth or a negative x to the ninth? Why do you say positive, Hadley? Well, look, all of my positive graphs go up to the right, and my negative graph goes down to the right. Okay? So I'm going to leave these two for you to do at home. And I want to move ahead. Hang on a second. Oh, no, we're good. So look down at the next one. So I want to graph, let's call this one f of x. So in your y equals, I want you to graph 2x to the fourth minus 6x minus 4 graph. Okay. Looks like that. So for the next one, x to the fourth minus 11x to the third. Oops. X to the fourth minus 11x to the third plus 42x. Oh, thank you. Third minus 42. Oh my gosh. I'm not having very good luck here. Plus 42x squared minus 64x plus 32. Okay. So we have this W shape. So my end behavior on the first graph, as I move towards positive infinity, y goes toward, so the limit of f of x as x approaches infinity is what? Is positive infinity. As I move to the right, the graph goes up. Okay? Well, what is the limit of f of x as x approaches negative infinity? When I move to the left, what direction does y go? So if I look at this graph, if I move to the left, what direction does the y go? Up. So it is infinity. How come they're both the same in this case? It's an even-numbered polynomial. It's an x to the fourth. Is it possible for both of them to be down instead of up? What would I need to do? I would need to change my graph to be a negative. So if I change it to negative 2x to the fourth, let's see if that does it. So second, insert a negative and graph it. All of a sudden, well, it's not that easy. Let's do, I know. Okay. So I just made the whole thing negative. Now it opens down. So in general, what type of equation would that be? Odd. It could be x to the third, or x to the fifth, or x to the seventh, and so on. Okay? What type of graph would that be? It would be negative x squared, or negative x to the fourth, or negative x to the sixth, and so on. So on the end behavior, even numbers are either up and up or down and down. Odd numbers are up and down. It could be either way. So looking at the rest of this worksheet, so you have a lot of graphs you need to do. And then down at the bottom, question 5 on the second to last page. Questions 1 through 4 gave you 3 examples of each kind of polynomial and behavior. The two things that determine the behavior of a polynomial are the degree, and the degree is the biggest exponent, and the leading coefficient, meaning the number in front, if it's positive or negative. Use the table below to summarize the end behaviors of polynomials. So if your degree is odd and the leading coefficient is negative, what is the end behavior going to look like? If the biggest exponent is odd, what does that tell me about the end behavior? They're opposite. Okay? So if that first number is negative, am I going to start negative or start positive? Is the left side going to be negative or positive? The left side would be positive, so we can draw a picture like this, and the right side will be negative. Okay? If the degree is even and the leading coefficient is negative, what is the end behavior going to look like? They're both going to be down. So it would be something like this. I don't know what's going to happen in the middle, but I know eventually it's going to be down and down. Okay? And then on the other side, it's going to be exactly the opposite. So it's going to be up and down, and this one is going to be up and up. Okay? So then on the last page, let's get rid of the last page. Don't worry about the last page. Yeah, you can just cross it off. So your assignment is to go through and graph the remainder of those equations and then write the limits. You need a x approaches infinity limit and an x approaches negative infinity. You have 4 minutes in class. Please don't waste that time.